Explorer 1, NASA's farthest traveling rocket, proceeds with its astonishing endeavor through space, perfectly conveying huge data from the most profound region of the universe. For nearly 50 years, this extraordinary space test has changed how we might interpret space. Anyway, actually, the space device has been conveying upsetting data back to Earth, leaving the whole space industry in shock. Are these alarming signs the consequence of a technical breakdown or the exercises of extraterrestrials? Join us as we uncover the truth behind these dazzling transmissions. Since the dawn of history, analysts have been captivated by the privileged insights that lie beyond our magnificent limits. This interest provoked the memorable send-off of the Explorer 1 and Pioneer 2 transports, among other superb space missions. These groundbreaking missions, which had been examined for a long while, started with the send-off of Voyager 2 from NASA's Kennedy Space Center on August 21, 1977. 14 days after the fact, on September 5 of that very year, Explorer 1 followed after. Accordingly, these twin tests, each gauging a critical 720 kg, practically identical to a little vehicle, were moved into space during a novel arrangement of the outer planets. All through their stunning odyssey, these brave journeys explored various bearings and velocities, leading to a pivotal moment on December 15, 1977. When Voyager 1 outperformed its indistinguishable twin because of varieties in their ways. From that point forward, Explorer 1 has become a huge asset, providing us with an abundance of data and disentangling space-related mysteries. Before we dive into Voyager 1's alarming new revelation that staggered the entire space industry, we should investigate the remarkable pictures caught by the rocket during its significant Jovian imaging mission in 1978. Pioneer 1 was situated around 265 million kilometers from Earth. From this vantage point, it imparted a dazzling number of photographs back to Earth. In January 1979, it set out on an outstanding 100-hour endeavor, capturing a hypnotizing time-lapse film showing 10 pivots of Jupiter. A cornucopia of 3,750 pictures permitted us to observe Jupiter's wonderful dance in clear detail. In the following months, Voyager 1 meandered through the Jovian moon framework, making a striking disclosure: the presence of a little ring surrounding Jupiter and 2 new moons, which further expanded how we might interpret Jupiter's intriguing area. To guarantee safe entry and for all a likely impact with Titan, one of Saturn's moons, remedial moves were executed. Pioneer 1 proceeded with its divine journey around Saturn, revealing 4 extra moons: Mimas, Enceladus, Tethys, Dione, and Rhea. With the climax of the Saturn mission, scientists chose to finish up the Pioneer planetary mission, pushing both Voyager 1 and Voyager 2 past the limits of our planetary gathering, jumping through space at a shocking pace of 325 million kilometers every year. In January 1990, another part started, the Voyager interstellar mission. During this stage, Voyager 1 conveyed some of the most famous photographs in history, immortalizing the Sun and the majority of the planets. One individual who played an essential role in broadening the missions beyond their initial goals was the prominent space expert, Dr. Vasil Sands. As a part of the Voyager mission's imaging team, Dr. Sands fervently upheld for catching one last arrangement of pictures as a farewell gift to humanity. Against all odds, his unflinching determination bore fruit on February 14, 1990, when Voyager 1, situated 6 billion kilometers from the Sun, set out on a visual journey notable as the planetary group family picture. These staggering pictures, adding up to 60, added to the transport's striking assortment of 670 photographs. During its encounter with Neptune, Voyager 2 accomplished an remarkable achievement by recording wind speeds exceeding 13,100 meters per second, making it the fastest wind of all time reported inside our planetary system. As the rocket wandered within 280 mil of Neptune's blue methane air, it furnished us with surprising bits of insight into this far-off heavenly body. Strikingly, Neptune's largest moon, Triton, was uncovered as perhaps the coldest occupant within our planetary group, with surface temperatures plunging to a cold -391 F. Triton's impossible to mishap highlights, for example, its nitrogen gas regurgitating ice volcanoes that drove frosty particles 5 miles into its amorphous air, likewise spellbound our creative mind. These extraordinary revelations extended our appreciation of the immense assortment and intricacy of heavenly objects living in the farthest reaches of our near-B planetary group. Don't go anywhere. The Pioneer 1 rocket has as of late made quite possibly of its most startling disclosures. However, first, we should figure out what it has accomplished in the most recent 45 years. The achievements of the Pioneer twin tests have been nothing shy of uncommon. More than many years ago, their underlying observations of Jupiter and Saturn's moons left researchers in awe and broke past assumptions about these distant universes. These moons, once believed to be lethargic and vigorously scarred like our own moon, ended up being abounding with geological movement. Pioneer 2 specifically accomplished several remarkable accomplishments during its excursion. It left a mark on history in 1986 by turning into the main transport to fly by Uranus. Only 3 years after the fact, it accomplished another surprising accomplishment with a flyby of Neptune. Up to the current day, it stays the sole rocket to have wandered on such a way. As the Pioneer rockets proceeded with their excursion, NASA executed different measures to expand their operational life expectancy. Over later years, unnecessary parts and warmers have been deactivated to conserve energy, ensuring that these gallant pilgrims can proceed with their main goal well into the following decade. Their estimated mission end date is set for 2030. For the researchers and specialists who have been engaged with this astounding undertaking from the very beginning, the finish of the Pioneer mission is both a snapshot of pride and a hint of melancholy. Their enduring dedication and passionate endeavors have far outperformed their underlying assumptions. The abundance of information returned by the pilgrims has given significant insights, fueled various logical disclosures, and ignited the creative mind of countless specialists and space enthusiasts. Pioneer 1 and Voyager 2 were no ordinary space tests. They were carefully designed as steady stages with a turn rate over 15 times more slow than the hour hand of a clock. This design decision limited visual obscuring as the rocket caught pictures and information while venturing through the infinity of room. Indeed, even before their experiences with the external planets, their great imaging capacities started to amaze researchers and the public alike. The rocket began communicating pictures of Jupiter prior to arriving at the gas giant. These early pictures showing the twirling mists and the notable Great Red Spot pleased crowds at NASA's Jet Propulsion Research Laboratory. However, it was the disclosure of active volcanoes on Jupiter's moon Io that genuinely took the spotlight. Io, somewhat larger than Earth's moon, ended up being the most volcanically active body in our solar system. The rocket's instruments distinguished exceptional signs from Io, which were confirmed by the unmistakable pictures they caught. Transcending volcanic crests and a surface scarred by volcanic ejections were revealed. Quite possibly Io's most conspicuous volcanoes have emitted with a force multiple times more noteworthy than Mount St. Helens, covering an area practically the size of France while the shuttle cameras were at last shut down to preserve power and memory before their journey into interstellar space. These groundbreaking observations were just the beginning. Besides the Voyager 1 and Voyager 2 interstellar tests, NASA has also worked on other notable rockets like Voyager 10, Voyager 11, and New Horizons. Voyager 1 passed by Voyager 10 on February 17, 1998, marking the occasion when Voyager 10 became the most distant spacecraft. Voyager 1 continued its lone excursion for 14 extra years before finally entering the interstellar climate on August 25, 2012. Although there could have been no other space tests in sight to observe, NASA didn't publicly report this astounding accomplishment until 2013. What strategy ensured the achievement of the Pioneer missions? One strategy stood out as particularly brilliant: gravity assists. These assists played a critical role in propelling Voyager 1 and Voyager 2 on their daring mission to explore the outer scopes of our planetary system. To reach these far-off destinations and gather significant data, the shuttle required more than just their own propulsion systems. They required a boost, and gravity assists provided precisely that. Imagine the two bold rockets, Voyager 1 and Voyager 2, leaving on their great tour through the local planetary system. Rather than depending solely on their engines, they participated in a heavenly hit-the-dance floor with some of our local planet's heavyweight planets, forming slingshot moves that played out in a fantastic dance. Using the huge gravitational draw of these monsters to sling themselves on their way, This technique allowed them to conserve significant fuel and gain the necessary speed to visit different destinations. Diving into the fundamentals of gravity assist, otherwise called a gravitational slingshot, we see that the idea behind this move is to move a portion of a planet's energy to the space apparatus as it cruises by. Envision, for example, investigating one drawing closer to Jupiter, a massive gas monster with a coordinating gravitational draw. With careful precision, Voyager 1 came around Jupiter at the perfect point and speed. Jupiter's gravity pulled at the rocket, speeding it up to a higher speed and furnishing it with a significant lift. Performing a gravity assist move requires outstanding accuracy. If Voyager 1 had drawn closer to Jupiter at some unacceptable point or speed, the slingshot could have brought about a mad deviation from its expected course. The degree of precision required is overwhelming, but the brilliant minds behind these missions executed these gravity assists multiple times, moving the Voyager space apparatus on an amazing journey through the local planetary system. Voyager 2, for instance, utilized gravity assists from Jupiter and Saturn to arrive at Uranus and Neptune. These divine moves were of vital importance in making the amazing tour possible. The Pioneer missions owe much of their success to these gravity assist moves. Voyager 1 proceeded to reach interstellar space, with Voyager 2 quickly following beyond our familiar limits. As we await further data from the ongoing investigation concerning Voyager 1's inconsistencies, let's reflect on the exceptional journey of these pioneering rockets and the wealth of information they have provided us. Explorer 1, NASA's farthest traveling rocket, continues its remarkable journey through space, transmitting vast amounts of data from the deepest regions of the universe. For nearly 50 years, this pioneering space probe has revolutionized our understanding of space. However, it has also encountered challenges, raising questions about technical malfunctions or even extraterrestrial interference. Join us as we delve into the story behind these intriguing transmissions. Since ancient times, humanity has been fascinated by the mysteries lying beyond our earthly boundaries. This curiosity led to the historic launches of Explorer 1 and Pioneer 2, among other groundbreaking space missions. These missions, meticulously planned and executed, aim to explore the outer reaches of our solar system and beyond. Voyager 1 and Voyager 2, twin probes each weighing approximately 720 kg, were launched in 1977. Their trajectories took them on separate paths through the outer planets of our solar system. Voyager 1, slightly ahead due to its trajectory, achieved a significant milestone on December 15, 1977, surpassing its twin Voyager 2. Since then, Voyager 1 has provided an invaluable source of data, unraveling mysteries of space and expanding our understanding of the cosmos. Before delving into Voyager 1's recent startling discoveries, let's examine the remarkable images captured by the probe during its historic Jovian imaging mission in 1978. Positioned approximately 265 million kilometers from Earth, Voyager 1 transmitted a staggering number of photographs back to Earth. In January 1979, it embarked on an ambitious 100-hour mission, capturing a mesmerizing time-lapse video showing 10 rotations of Jupiter. This series of 3,750 images provided unprecedented insights into Jupiter's dynamic atmosphere and swirling storms. During subsequent months, Voyager 1 navigated through Jupiter's moon system, making a startling discovery: a faint ring encircling Jupiter and two previously unknown moons. These findings expanded our understanding of Jupiter's complex planetary system and set the stage for further exploration. Ensuring safe passage through Saturn's treacherous moons required precise navigational adjustments. Voyager 1 successfully maneuvered around Saturn, revealing 4 additional moons: Mimas, Enceladus, Tethys, Dione, and Rhea. These discoveries underscored the diverse nature of Saturn's satellite system and demonstrated Voyager 1's capabilities in deep space exploration. In 1990, Voyager 1 embarked on its interstellar mission, capturing iconic images of the solar system's planets from unique vantage points. These images, including the famous pale blue photograph of Earth, became symbols of humanity's exploration of the cosmos. Dr. Vasil Sands, a prominent astronomer involved in the Voyager missions, advocated for capturing a final series of images as a tribute to human ingenuity and exploration. Voyager 1's journey continued beyond Neptune, where it recorded wind speeds exceeding 1,300 meters per second and made groundbreaking discoveries about Neptune's largest moon, Triton. Voyager 1 revealed Triton is one of the coldest bodies in our solar system, with surface temperatures plummeting to -391 degrees Fahrenheit. The probe's instruments observed nitrogen geysers and icy volcanic eruptions on Triton, providing scientists with valuable insights into this distant world. Throughout their missions, Voyager 1 and Voyager 2 exemplified resilience and innovation. NASA implemented measures to extend their operational lifespans, including deactivating non-essential systems and heaters to conserve energy. These efforts ensured that the probes continued to transmit data and images from the far reaches of our solar system.